Block 1. The Physics Pioneer Denied. Lise Meitner's Legacy. Welcome, science enthusiasts, to a story that will shake your understanding of history, justice, and the very fabric of reality. We often picture scientific discovery as a clean, linear path. A brilliant mind has a eureka moment and the world changes overnight. But the truth is often far messier, tangled in the thorns of politics, prejudice, and personal betrayal. Today, we delve into one of the most profound injustices in the annals of science. A story of a mind so brilliant it unlocked the power of the atom only to be cast into the shadows while others claim the ultimate prize. We are talking about the incredible, the indomitable, and the tragically overlooked Lise Meitner. Our story begins in the early 20th century, a golden age of physics. Giants like Einstein and Planck were rewriting the rules of the universe. Into this electrifying world stepped Lise Meitner, a young Austrian woman with a passion for physics that burned brighter than the radium being studied in the labs of Paris. But for a woman in science at that time, passion wasn't enough. She faced a wall of institutional sexism. At the University of Vienna, she was only the second woman to earn a doctorate in physics. When she moved to Berlin to study with the great Max Planck, she was initially barred from the main laboratories, forced to work in a cramped wood shop in the basement. It was there she began a collaboration that would last over 30 years, a partnership that would both define her career and ultimately lead to her heartbreak: her work with the German chemist Otto Hahn. Hahn was the meticulous experimentalist, Meitner was the profound theoretical physicist. Together, they were a perfect team, a symphony of chemistry and physics. For decades, they were at the forefront of radioactivity research, discovering new isotopes and pushing the boundaries of what was known about the atomic nucleus. But as the 1930s dawned, a dark shadow began to creep across Europe. The rise of the Nazi Party in Germany changed everything. Meitner, who was of Jewish descent, was suddenly no longer a respected scientist but a target. Her Austrian citizenship had offered her a thin veil of protection, but in 1938, when Germany annexed Austria in the Anschluss, that veil was torn away. She became a stateless refugee in her own laboratory. Her colleagues, including Otto Hahn, watched with growing alarm as her situation became untenable. In July 1938, with only 10 marks in her pocket, she was smuggled across the border into Holland, a dramatic escape that saved her life but severed her from her life's work. From her lonely exile in Sweden, Meitner continued her collaboration with Hahn through a frantic exchange of letters. Back in Berlin, Hahn and his assistant Fritz Strassmann continued the experiments they had all designed together, bombarding uranium with neutrons. But their results were baffling. They weren't getting the heavier elements they expected. Instead, they found barium, an element about half the size of uranium. Hahn was stumped. In a letter to Meitner, he wrote in near desperation, "Perhaps you can come up with some fantastic explanation." He, the chemist, couldn't fathom how a large uranium nucleus could possibly yield a much smaller barium atom. It was like throwing a rock at a window and expecting it to turn into two smaller, perfectly formed windows. And here, in the cold of a Swedish winter, comes the pivotal moment of discovery. During a Christmas holiday walk in the snow with her physicist nephew, Otto Frisch, Meitner contemplated Hahn's bewildering results. The image of the nucleus as a hard, solid ball, a view held by most physicists, simply didn't work. But Meitner recalled a different idea, the liquid drop model, which envisioned the nucleus behaving like an unstable drop of water. As she and Frisch walked, the pieces clicked into place. A neutron hitting the large, wobbly uranium nucleus could cause it to elongate, stretch, and then, like a water droplet breaking apart, split into two smaller droplets, two smaller nuclei, like barium. But where did the energy come from? Sitting on a log in the snowy woods, Meitner did a quick calculation on a scrap of paper. She realized that the two new nuclei were slightly less massive than the original uranium nucleus. This tiny amount of lost mass, she reasoned, must have been converted into an enormous amount of energy, precisely as predicted by Einstein's famous equation E equals mc squared. She had not only explained the how, but also the why. She and Frisch named the process nuclear fission. She immediately communicated her earth-shadowing explanation to Hahn. It was the key that unlocked his data, the theoretical framework that turned a chemical anomaly into a revolution in physics. Yet, when Hahn published the experimental results in 1939, he downplayed Meitner's role, vaguely mentioning her contributions as if she were a distant junior colleague rather than the intellectual leader of their team for 3 decades. The reasons were complex, perhaps fear of associating with a Jewish scientist in Nazi Germany, perhaps a simple inability to fully grasp the physics he had observed without her. The result, however, was singular and devastating. In 1944, the Nobel Prize in Chemistry for the discovery of nuclear fission was awarded to Otto Hahn alone. Lise Meitner, the woman who had guided the research for years, who had provided the crucial theoretical breakthrough, and who had even coined the very term for the discovery, was completely erased from the honor. Her work laid the foundation for both the terrifying power of the atomic bomb and the promise of nuclear energy, yet she was denied her rightful place in history. Her story is a chilling reminder that even in the pursuit of objective truth, science can be deeply and painfully human. What do you think is the single biggest factor that led to Lise Meitner being overlooked for the Nobel Prize? Share your thoughts in the comments. Subscribe for more hidden stories, and we'll see you in the next one.